Professor Pelton. This is Algebra 2, Chapter 5, Section 1, dealing with radicals again. So if you have a rational exponent of 1 over n, doesn't matter what the n is, as we said in the previous section, it can be converted back and forth to the radical form. So you can go back and forth between the radical form and the exponent form. If there's a negative, however, that takes precedence in the order of operations. So you get 1 over a to the 1 over n, using the negative exponent rule, which is reciprocal, which is 1 over the nth root of a. Okay, so let's do some example problems. I'll have you do some. So this is really the 4th root of 1296. It's probably easier to use the radical form than is the exponent form in a lot of cases. That's why we have go back and forth. Okay, so if I break that down, let's see here. That is the 4th root. What ends in a 6, that's divisible by 2. So that's 2 times 648. Okay, let me think here. So there goes 2 again. So that's 2, 2, 3, 24, if my math serves me correctly. So that is the 4th root of 2, 2. Well, 324 is also divisible by 2. So that's 2 again, and 162. So that's the 4th root of, let's see, 1, 2, 3 2s. 162 is also divisible by 2. So that's 81. And that's 2, 2, 2, 2. 81 is 9 times 9, which is 3, 3, 3, 3. So that's the prime factorization using the fundamental theorem of arithmetic. So I have 4 2s and 4 3s for 2 times 3 for a final answer of 6. Okay, next one is a negative exponent. So we need to do the negative exponent rule first. So it's 1 over the 3rd root of 512. Okay, so we'll break down 512. That is 2 times 256. A little extra wing there we'll get rid of. Which is the 3rd root of 2 times 2 times 128. Which is the 3rd root of 2 times 2 times 2 times 64. Which let's see here, did I get that right so far? Yep, so 64 is 8 times 8. So that's 2 times 2 times 2, and then 3 more for 8, and 3 more for 8 again for 8 times 8. So if I look here, I have 1, 2, 3 groups of 2. So that's 1 over 2 to the 3rd, since there's 3 2 groups. So that's 1/8 is my final answer. And the next one, you can rewrite it if you want, but the answer is 1. Okay, 1 to any power is 1, even 0, because that's the 12th root of 1. 12 ones is still 1, right? Okay. All right, pause the video, try the student problems for yourself. Okay, so we have a negative one to start off with, so that's 1 over the 6th root of 729. So let's see here. 7 plus 2 is 9. 9 plus 9 more is 18. So if 18 is 8 plus 1 is that's divisible by 3. So that is the 6th root of 3 times 243. Right? 7 plus 2 plus 9 is 18. 8 plus 1 is 9. That's divisible by 3. So let's see here. 2 plus 4 plus 3 is 6. That's 9. That's divisible by 3 also. So that's 3 times 81. So that gives me 3 times 3. 81 is 9 times 9. So we have 6 3s all together. So it gives me an answer of 1 over 3, 1/3. So essentially what I have is the 6th root of 3 to the 6th, if I think about it, right? Should cancel out. Okay, so this is the 5th root of 32. And 32 is 4 times 8 for the prime factorization. So the answer is 2. And the last one, you can write it out if you want to, but it's 1. Any power to 1 of 1 to any power is just 1. Okay, well, all of those have numerators of 1, which means an exponent of 1. So if you don't have an exponent of 1, we need to account for it. So if I have m to the n power, that is the nth root of a to the mth power, or the nth root of a to the m power. It's probably easier to put on the outside in most circumstances, but it's going to depend on what you're doing and if you want to combine things or break things apart. So it's going to depend. Either way, think of it this way. Numerators make you bigger, denominators make you smaller. Radicals make you smaller, exponents make you bigger, typically if it's a whole number anyways. The caveat being if there's a negative exponent, that must come first. So thus 1 over the nth root of a to the m, that should be or 1 over the nth root of a to the m. So either one of those is sufficient. Okay, so we go here, and if I rewrote this, it would be the square root of 4 to the 5th, or the square root of 4 to the 5th. I really don't want a 4 to the 5th. I can't do that in my head. But I can do the square root of 4, that's 2. And 2 to the 5th is 32, which is the correct answer. Okay, if I did it the other way, it's going to be 4 times 4 times 4 times 4 times 4, right? So there's 2 of those and 2 of those, and that's 2 times 2, which is 2 of those. So that's 4 times 4 times 2, which is still 32, 8 times 4, right? But having the exponent on the outside tends to be easier for these nice whole number ones. So that's what I recommend. You don't need to do it the other way, although we do need the other way in certain circumstances for the equations. So this is 1 over the 4th root of 81 to the 3rd. So the 4th root of 81, let's see, 81 is 9 times 9, which is 3333. So the 4th root of the 81 is 3. So this is 1 over 3 to the 3rd, or 1/27th. All right, next one, 1 to the 7/8. Well, if you've been paying attention, that's just 1, correct? You're welcome to rewrite it if you want, but you can do the 8th root of 1 and the 1 to the 7th power, you still get 1. Okay, here's tricky, you got to pay attention. Does that negative apply to does the 1/4 apply to the negative, the 16, or both? It's only the 16, okay? Because if I have 5 minus 16 to the 1/4, right, exponents come first, subtraction comes second in the order of operations, doesn't it? Or pick any number you want. It doesn't have to be 5. What's your favorite number? Is your favorite number 8? Your favorite number 9? Doesn't matter. Whatever number you pick. So this is negative 4th roots of 16. So this is negative 4th roots of 16 is 2, 2, 2, 2. 4 times 4. So that's an answer of 2. So the answer is negative 2. All right, pause the video. Try the student problem. Okay, so the next one we have the square root of 16 to the 3rd. You can put the 3rd power on the inside or the outside. I choose the outside. So the square root of 16 is 4. 4 to the 3rd is 64. Okay, next one has a negative, so I must do 1 over the 5th root of 32 to the 3rd power, or 1 over, let's see, 32 is 4 times 8, so that's 4, and that's 8. Oh, sorry, that's 3rd power, sorry. So that's 5, 2, so that's 1 over 2 to the 3rd, or 1/8 is our answer. Okay, next one, 1 to the negative 3/4. Again, you can do it out if you want to. Either way, you get 1, because this is 1 over 1 to the 3/4, or 1 over the 4th root of 1 to the 3rd power, which is still 1 over 1, which is still 1. You're welcome to do that longhand, but again, just remember the 1 rule. It's not really a rule, it's just kind of common sense. All right, in this case, a little bit different because since there's parentheses, the 3/5 applies to the negative and the 32. So this is the 5th root of negative 32, all to the 3rd. So this is 5, and 32 is 4 times 8. So that's 4 times 8, because I have 5 negatives is still negative. So that's negative 2 to the 3rd, because this is still the 3rd. And 3 negatives is still a negative 8. Okay, let's go to page 4. All right, solving equations. Since there is only a singular x of a singular power, we can just use isolation strategy, which is order of operations backwards. So order of operations backwards, add, subtract step, add 8. So 4x to the 5th equals 128. Multiply, divide, we'll divide by 4 on both sides. So x to the 5th equals 32. Exponent radical, do the 5th root and the 5th root. So x equals 2. We don't need a plus or minus here because it's an odd root. And we don't end up doing the grouping symbols because there isn't any. Okay, next one, add, subtract step, -1. Properties of equality dictate you do things to both sides, correct? Multiply, divide, divide by 2, x minus 3 to the 4th equals 21. Exponents and radicals, the 4th root of x minus 3 to the 4th equals the 4th root of 21. But this is an even root, so we need a plus or minus. So those cancel. I'm left with x minus 3 equals plus or minus the 4th root of 21. And then the grouping symbol says add 3. Well, 3 and 4th root of 21 are not like terms. Those cannot be added. So that is 3 plus or minus the 4th root of 21, which is 2 different answers. But that's fine. Okay, pause the video, try the student problems for yourself. So again, each of these problems have a singular power of x, so factoring is not needed. Use isolation technique. Add, subtract, subtract 12. So 1/2 of x to the 5th equals 512. Multiply, divide. We'll times it by 2 on both sides, which is the reciprocal of 1/2. So x to the 5th equals 1024. So then we have exponent radical. So we need the 5th root of x to the 5th equals the 5th root of 1024. Plus or minus is not needed since this is a 5th root. So let's see here. X equals, so there's no grouping symbol. Let's just simplify now. 1024. We've actually done this one before, so that's 2 times 512. And let's see. 2 times 2 times 256. So that's 2 times 2 times 2 times 128. 2 times 2 times 2 times, it's 2 times 64, right? So one more 2 gives me 2 times 64. 64 is 8 times 8. Okay, so we have 1, 2, 3, 4, 5 2's there. 1, 2, 3, 4, 5 2's there. For 2 times 2, so my answer is 4. Okay. All right, next one. Add, subtract step, -1. So we have 3x to the plus 5 to the 4th equals 48. Multiply, divide. Divide by 3, divide by 3. X plus 5 to the 4th equals 16. Exponent radical. 4th root of x plus 5 to the 4th equals the 4th root of 16. That's an even root, so we need plus or minus. So we have x plus 5, cancel, cancel, equals, let's see, that'd be plus or minus 2, because 16 is 2, 2, 2, 2, right? Grouping symbol step, -5. X equals, X equals. So just like before, we have 2 answers. 2, positive 2 minus 5 is -3. -2 minus 5 is -7. So we have 2 answers in this case. Okay, that is the end of part 2.